Today we're going to be talking about exponential and logarithmic functions and the properties of logs. And so let's take a look at some of our logarithms. Now notice we have the common logarithm is a logarithm with a base of 10. So they're not always going to write that base of 10. So if you see log of x, just know it's assumed to be a base of 10. Same thing with a natural log. So a natural log's base is e. And so we can say log of e, but that's the same thing as saying the natural log or ln of x. Also take notice, I've also put on there how you change a log to an exponent and a natural log to an exponent and back. And so you will want to make sure that you refer to this section right here when you were talking about changing from logarithmic to exponent form or exponent to logarithmic form. Now let's jump into the properties of logs. This is what we're going to primarily be working with today. Each logarithmic has their own properties. So we have the product rule, the quotient rule, the power rule, the inverse property, and the one-to-one property. And then we also have changing a base. And so we're going to go through each of these real quick. Now, a product rule would be when you have multiple things multiplied together. So if you look here, when we've got, the log of m times n, you can expand that out to read log of m plus log of n. So we separate them out by expanding it. Think about back when you were in elementary school and you had to take a certain number, so let's say 1,536, and you had to write that in expanded form. So what you would have to do is you would have to write out the 1,000 plus the 500 plus the 30 plus the 6. So this was standard form when it was all put together. This was expanded form. And so we're going to be talking a lot about expanding and compressing. So with logs. So the product rule is just one example of that, how whenever you have multiple things multiplied together, we can expand it out by putting it, separating each log with a plus sign. Now, same thing with quotient rule. So let's say you have two things divided. This would be our standard form where you have one single log with m divided by n. But if we wanted to expand that out, we could write, log of m minus log of n, and that would be written out in expanded form. So product, think plus, quotient, think minus. Now, let's talk about the power rule, because the power rule is something that we use all the time with logs. The power rule tells us that n is our power. Now, what we can do is we can drop that power down in front of our log. So notice you can rewrite it like that. And so sometimes that helps us with solving and so forth. Now, always remember the log of 1 is 0 and the natural log of 1 is 0. So that's going to come in handy when we are trying to solve or expand or compress. You can remember that the log of 1 is 0 and so is the natural log of 1. And then we also have our power rule here, where if you can make your bases match, then your answer, or what it equals, is x. So your exponent is what it equals. Same thing for a natural log. So if you can make your bases match, where you have an e and an e, then your exponent is going to be whatever it equals. Now, let's look at our changing of base. So remember, our given base for a log is log base 10. And our given base for a natural log is e. So anytime that we are writing and they want us to change bases, move it from, let's say, log base 5, and they want us to write it in a standard base, which would be base 10. So let's say I have the log of 5 of 21, for instance, and they wanted me to change the base. What you can do is you can simply write it as the log of this big base. So I would write it as log of 21 divided by the log of the little base. So log of 5. And there you have it. That's how you would change a base. Same thing with a natural log. If they wanted you to write it with a base change in a natural log, the same thing still applies. It's just that you would use an ln instead of a log. And that's how you're going to change some bases. So let's take a look at our first example, because they want us on example 1 to use our changing of base to help us rewrite some logs. So it says rewrite the logarithm as a ratio of common logarithms, that would be the log, and natural logarithms, that would be the ln. So if they give us this log and they say rewrite it as a ratio of common logs, I'm going to say log of the big B, which is x, divided by log of the little b, which is 5. And that's as far as you have to take it. So that takes care of part A. Part B, you're going to do the exact same thing. It's just that you're using ln instead of log. So here I would have ln of the big base, x, divided by ln of the little base, 5. And that would be writing it as a ratio. So on part B, it's going to be the same thing. Don't let the fraction throw you. So here I would have log of 3/10, so log of big B, divided by log of little b, which is a. And that would take care of part A. So I'm going to do the same thing for part B, just use ln instead of log. So here I would have ln of 3/10 divided by ln of a. And that's how you change it from having whatever base you have to a base of 10 or a base of e. Now we're going to evaluate the logarithm using the change of base formula. So here's where our calculator comes into play. So you'll need to get your calculator out, and we're going to actually go ahead and calculate this out. So I'm going to say log of big B, which is 7, divided by log of little b, which is 3, and go ahead and plug that into your calculator. Now, anytime we take a log of a number, it's just going to be a number. So you're doing log of 7 in your calculator divided by log of 3. And that's going to give us approximately, now it says round to 3 decimal places, 1.771. And that's your solution. So I'm going to do the same thing on part B. I'm going to say log of 0.9 divided by log of 6, and plug that into my calculator, and that gives me negative 0.059. And there you have it. Now what we're going to do is we're going to use the properties of logs to rewrite and simplify the logarithmic expression. So what we're going to do here is our goal is to use those properties of logs that we just talked about in order to write it as simple as we can make it. So on the first one, now notice the 4 and the 8, I can get those both down to where they have a base of 2. And so that's exactly what I'm going to do. But this time around, rather than just dividing it, I'm going to use my log properties in order to get that simplified. So first off, I'm going to start by just changing 8 into 2 to the third. Okay, so that is how I would write it, rewrite my big base of 8 to have a new base of 2. Now, I'm going to use my log properties to drop my exponent down to the front. So notice, I'm going to rewrite it like this. Log base 4 of 2. Now, let's think about how could I write 2 where it has a base of 4. So let's think about how we could rewrite 2 to where it has a base of 4. 4 to what power gives me 2? And that's going to be a half. And so this is where you kind of have to think outside the box. You have to think really hard about your bases and exponents and what things equal. So this is what I could have. Log base 4 of 4 to the 1/2. Now again, I can use that property where I drop my exponent down to the front. So I'm going to essentially multiply 3 times 1/2. So 3 times 1/2 gives me log 4 of 4. Now, because my bases equal, this whole thing is going to change into 1 because that's the exponent on that 4 right there. So I can take, once your bases match, essentially this goes to 1. So then what I have is I have 3 times 1/2 times 1, which is 3/2. Now, that seems a little confusing because you're having to kind of think outside the box as far as, you know, the 2 we had to realize was 4 to the 1/2. I've taught you in the past where you can make your bases match and just divide the exponents of the 2, and you can still do that. That is totally acceptable. But I just wanted to show you how we use some of our properties in order to get that. So here on part B, notice I have 2 things that are multiplied. Now, what I can do is I can go ahead and expand that out. So in other words, I can separate that 4 squared and the 3 to the 4th. I can go ahead and separate those by splitting it into 2 logs with a plus sign. So if you notice, I can do this. This is 4 squared plus log base 2 of 3 to the 4th. Now, what I'm going to do is I'm first going to drop down that exponent to the front. Both of them. I'm going to drop them in front there. So then this is going to read 2 log base 2 of 4 plus 4 log base 2 of 3. Now, I'm going to look at each individual log and see, is there a way that I could make these bases match? So on my first pair, where I have a 2 and a 4, I can make the 4 become a base of 2. So that's exactly what I'm going to do. I could rewrite 4 as 2 squared so that these bases align. Now, is there anything that I could do to the number 3 to where I could make it become a base of 2? And the answer there is no. So on that part, this is as simple as you can write it. So I'm just going to recopy what I've already got. And now I'm going to work on this front end part because I can drop that 2 down in front now. 2 times 2 makes 4. So what I've essentially got is I've got 4, and then I've got log base 2 of 2 plus 4 log base 2 of 3. Now remember what we just talked about. Our property says when your bases match, that essentially goes to 1. So what I've essentially got is I've got 4 times 1 plus 4 log base 2 of 3, which gives me a solution of 4 plus 4 log base 2 of 3, and that's your final answer. So we're going to do the exact same thing for part C. We're going to separate, notice, that 5 is multiplied to the e to the 6. So that is like 2 things that are being multiplied together. Remember, based on our product rule, we can separate those 2 with a plus sign. So I'm going to go ahead and do that. I'm going to say ln of 5 plus ln of e to the 6th. Now, the reason that I want to do that is because I can drop that 6 down in front. So then it's ln of 5 plus 6 ln of e. And remember, we've already talked about ln of e, because the bases match, it goes to 1. So that's like 6 times 1, which is 6. So my final answer is going to be ln of 5 plus 6. And that is as simple as you can make it. So that is your final answer. Now, example 4, it says use the properties of logs to expand the expression as a sum, a difference, or a constant multiple of logs. Okay, so we're going to basically do everything we can to expand this out as much as we can. Now notice on this I have a 5 times an x. So view those 2 things as if they're multiplied, 5 times x. Now the reason you want to do that is because you can expand it out with a plus sign if they're multiplied using the product rule. So there's that one. And the thing about expanding is it's going to keep the same base throughout. So that is what you have when it's expanded out. And that right there, there's nothing more that I can do to that to simplify. So log of 5 plus log of x is how you would write your answer. Now notice they put the 10 here, but would they have to put the 10 there? They do not, because it is the given base for a log. Now let's look at part B. Notice I have A times B times C. So I'm going to first pull them apart into a log A, a log B, and a log C. So I'm going to write log base 6 of A plus log base 6 of B cubed plus log base 6 of C squared. Now, the final thing is to make sure that you have dropped your exponents down. They don't like to see exponents in your final expanded answer. So what I'm going to do is I'm going to take the 3 and the 2 and I'm going to go ahead and drop it down in front. So then my final answer will read log base 6 of A plus 3 times log base 6 of B plus 2 log base 6 of C. And that's how you would write your final answer in expanded form. So notice on part C, I've got a natural log here. But the first thing that I'm going to do is I'm going to go ahead and split up my fraction. So notice that is the cube root of x divided by y. So first off, you've got to think about how you would write the cube root of something as an exponent. And so remember back to your exponent rules, you can write the cube root of something the same thing as raising it to the 1/3 power. So essentially what I'm going to do is I'm going to split my top and my bottom and I'm going to raise them both to the 1/3 power. That's saying the same thing as taking the cube root. It's just that we changed it to exponent form. The reason we want to change it to exponent form is so we can drop the exponents down in front. So now what I'm going to do is I'm going to use my property of logs and I'm going to go ahead and separate these out. Because it's division, we're going to use the quotient rule, which means we're going to separate them with a minus sign. So I'm going to write it as ln x to the 1/3 minus ln of y to the 1/3. And then the last step is going to be take your exponents and drop them down in front and write them multiplied to the log. So 1/3 ln x minus 1/3 ln y. And that's going to be how you write your final answer. Now on to part D. I've got several things here going on. So I have x to the 4th times the square root of y over z to the 5th. So I've got both multiplication and division in my problem. So first thing I'm going to do is you write anything that's multiplied on the top, you're going to separate with a plus sign. So I'm going to go ahead and separate all of these out. So I'm going to write that as ln x to the 4th plus ln square root of y. And then because the z to the 5th is in the bottom, I'm going to go ahead and write minus ln z to the 5th. Now notice all of them have exponents except for my square root. So what I'm going to try to do is I'm going to rewrite this as an exponent instead of a square root. How you rewrite an exponent, or the square root as an exponent, is y to the 1/2 power. Now, the last step, of course, is going to be taking my exponents on all of these and dropping them down to the front. And that's exactly what I'm going to do. So my final answer is going to say 4 ln x plus 1/2 ln y minus 5 ln z. And there you have an expanded form. Now we're going to go backwards. So we're actually going to take the expanded form and we're going to condense it to 1 logarithm. Okay, so think about what each of the symbols mean. On A, the only thing I have going on here is a minus sign, which means that I'm dividing z by y. So if I'm going to rewrite that as a single logarithm, I'm going to write log base 4. You always write the base. Always, always write the base. If it's not 10, like if it's not understood to be 10 or e, Those are the only exceptions to where you would not have to rewrite your base. So I have a log base 4 of z divided by y. And that would be writing it as a single log. So let's take a look at part B. First thing I have going on is I'm going to move, so think backwards. The last step was I dropped all my exponents down. So now what I'm going to do is I'm going to move them all back up to be exponents. So first off, I'm going to start by writing ln of x to the third plus ln of y squared minus ln of z to the fourth. So put your exponents back up where they belong. And then what I'm going to do is I'm going to use the pluses and the minus and write them as a single log where it needs to go. So remember, I'm going to write ln, and then I have these two are multiplied on top. So I have x cubed y squared divided by, because of that minus sign, z to the fourth. And that is how you would write it, as one log. So on part C, we've got, first I'm going to go ahead, see the 1/3 out in front? So I've got 3 things that I've got to distribute that to. Now that would be an exponent. So I'm going to go ahead and I'm going to distribute. 2 times 1/3 is 2/3 of ln x plus 3 plus, and then 1/3 ln of x minus 1/3, of ln of x squared minus 1. So what I did was I went ahead and distributed that 1/3 through. Now what I'm going to go ahead and do is move all of my exponents, I'm going to go ahead and move them up where they belong. Notice this is x plus 3, all of it's going to be raised to the 2/3 power. So when I move the 2/3 up, I need to keep the parentheses around that x plus 3. So what I've got is ln of x plus 3, all of that is raised to the 2/3 power, plus ln of x to the 1/3 minus ln, and again, same thing. I've got x squared minus 1 all in parentheses, so the whole thing is being raised to the 1/3 power. So now when I get ready to write my 1 log, I'm going to write ln, and then remember these two things are multiplied on top, so I'm going to go ahead and write x plus 3 to the 2/3 power times x to the 1/3 power, those are all on top, divided by, because of this minus sign, x squared minus 1 to the 1/3 power on bottom. And that is how you would write as one singular log. And that takes care of expanding and condensing logs using the properties.